Okay, so we ran a two-class model. We ran a three-class model. We determined that the two-class model was better than the three-class model. We have the evidence of a lower BIC for a two-class model, higher entropy. Just FYI, there's been a couple of papers that have suggested that entropy is a really bad way to determine whether or not, yeah, whether or not you should, like, it shouldn't be used to determine classes. But you do want to have an entropy greater than 0.8. Entropy is less than 0.8. It just lacks power to determine classes. But after that, assuming it's above zero point 0.8, it's kind of like our RMSEA thresholds and our other thresholds. If it's 0.6, that's terrible. We know that that's bad. But beyond zero point 0.8, it doesn't give us a ton of information. But we're above zero point 0.8 here. Entropy seems solid.
Can you share those papers?
I can probably look for it. I'll look for the paper on that one. Yeah, it's if you Google like power to detect classes, then you can find it. So I'll see if I can find it though. All right. If we scroll down, we see that all of our tests suggest that 2 is better than 1, and so we know that we're going to roll with a two-class model, right? The next thing that we want to do is look at this model. So you people in the front row, if you ran this latent class model, did you get a, did it give you your profiles afterwards? Did it pop up a figure for you to look at? No? Okay. Oh, I don't have it in the, when we switch over to latent profiles here in a second, it will. It should. We'll see. Maybe it won't. It doesn't on mine for sure because Macs don't do it. So, but I put in all of the data in the next one for the profile analysis to give you that plot. So we'll see if it gives you the plot or not. All right. The next step though is to graph these, right? And so the way that we're going to graph these is we are going to come down here and we're going to look at our different classes and our probability. And what we're really looking at is the probability of being in category 2 versus category 1. This is the same as a logistic model. If you add these together, it's going to be 1, right? So let's open up a new Word doc or a new Excel file. And if you haven't learned or like gleaned this from me yet, like I love using Excel for stuff. I feel like it's more flexible. I can do all kinds of stuff with Excel, and it's intuitive. If you spend a little bit of time in Excel, then you can make all kinds of graphs that are fantastic. I know that there are like specific things out there to make different types of graphs, and I feel like they're just harder to use than Excel. Maybe I'm wrong. Maybe you guys have something that you really love, but I just don't. All right, so what we're going to start with is we are going to say class 1, class 2, and then up here we're going to have item 1, item 2, item 3, and item 4, right? And then we are going to we're going to start with class 1, and we're going to get the item for category 2. That's a probability. So our probability here is 0.887. On item 2, our probability is 0.849. On item 3, probability is 0.089. It drops down, right? And on item 4, probability is 0.111. That is the likelihood of endorsing 1 if you are in class 1, right? Yep, go ahead.
I thought item 1, category 2 was.
It is.
Why is it under class 1?
Oh, this is latent class 1. This is, when it says category, what that means is, remember these are categorical variables. So it's your likelihood of endorsing category 0 or category 1. Or, I'm sorry, because it says 1 and 2, it would be category 1 or category 2, right? But this is items U1, right? And on item U1, you can either say I am this or I am this. And if you were in class 1, there is an 88.7% chance that you'll say I am this, right?
We're just going to look at this here.
Yeah, right, because it's a logit. So you're just concerned with the probability of moving up to one class. You could technically look at the other one if you wanted, and then just flip your scale. And so then the classes are going to be the probability of endorsing category 1. But just make sure that whatever you do, you stay consistent all the way across. So you could do either. It doesn't matter as long as you stay consistent. And the graph will look exactly the same either way. It just flipped, right? But all right. Then we go to latent class 2. And this is 0.11. This is 0.113. And then this is 0.899. And this is 0.874. So this is saying that in class 2, you have a very low probability of endorsing category 2 for item 1, and a very low probability of endorsing category 2 for item 2, a very high probability of endorsing category 2 for item 3, and a very high probability of endorsing category 2 for item 4. You can tell already that it's going to look something like this. You have your basic graph, 0, 1, and then this is item 1, 2, 3, 4. So for class 1, let's say, class 1, you're going to be, let's say that this is like 0.9, and this is 1. This is 0.8. What's the number here for this one?
887.
0.887. So it's going to be like right here. What's the number for number 2?
8.9.
Be down just a little bit. For 3,
0.9.
really low. 4, up a little bit higher. So it'll look something like this. That is class 1. All right, class 2 is what?
We don't even know that.
I'm just going to throw them in here because I know that it's going to look like this, right? And so you have these 2 different classes. When we graph this, it should look like roughly an X, right? Let's have a look. So we highlight our stuff here. I may have made this wrong. We might have to flip it. Let's go insert graph. Yeah, and that is what it looks like. And then you can, of course, go in and church it up. I think that this looks fairly ugly, right? But you can make them look really, really nice. And we will, for the next example, open up. And I gave you guys a figure that I've made to look really nice for latent profile analysis that you can go in and modify however you want for your own latent profile analysis types of stuff. There's no homework and it's not going to be on the exam, but you're more than welcome to use that. It's just an Excel file. Or better yet, make your own and make it your own and make it look cool. I'll just show you real quick the one that I've made that I put in the thing for you is, I'm going to open it because we're going to plug our values into it anyway. So this is the one that I made, and you can name your different classes. I did not list the items. Oh, the items are listed down here, and they correspond to things here. So you can make it look very, very cool. All right, let's switch gears now, and let's talk about latent profile analysis. So we're going to grab a new file. We are going to use one that says LPA audit.inp. Go ahead and grab that file and make sure that you grab the data file, put them in a folder. I'll give you guys a few minutes to do that. You can't find it?
I know, yeah. The file name for the LPA data says LCA,
Yeah, I'm sorry, it says LCA data.
but it's good.
Yeah, it's good. Yeah. So in this data set, we have audit scores, which are scores on a measure of alcohol pathology. It's broken up by 3 different factors: audit use, audit harms, and then dependence types of symptoms. We might do something else with this real quick. Actually, maybe not. Oh yeah, what the hell. We'll see at the end. I'm going to show you guys something. That has nothing to do with latent classes. I just like kind of something to be thinking about for next week when we start doing structural equation modeling. But anyway, so we have these audit scores, and everybody have this? Are we good to go now? We're going to change this to starts equals 20 and 5, type equals mixture. Class is 2 classes, right? And I'm going to scroll down and show you guys some things that I put in here. So one of the cool things that you can do, both with latent class and latent profile, is within the model, you can specify covariates, and they don't necessarily have to be covariates. If you want to know, are there differences in whatever value based on profile, you can put them in the model just like this, and it will tell you if those differences are there. So we're going to look at it here in a second. There's also another way to do something. If you sometimes you run into issues where it says like the variance won't work, like there's an issue with the variance. If there's an issue with the mean, it's less of an issue, but an issue with the variance, that might be an issue, in which case you would come in. So if it said, for example, that there's a problem with the mean or the variance of item 7 on class 3, then you could come here and you could say like C3 audit 7 at 0. You could fix that variance to be 0, right? A better approach is actually to constrain that variance to be equal to whatever the variance is in the larger data set. There is this idea that we have homogeneity of variance, and that extends across classes. And so if you fix that variance to be identical to what it is in the larger data set, there is some misspecification. It's not going to be perfect, right? But it's also saying like we're going to hold this variance constant. And we're going to hold it constant to the larger sample. That will usually fix variance issues. What you wind up seeing a lot in latent profile analysis are Haywood cases, right? Negative variances in certain classes. One of the other issues is how many people can you have per class, and what sample size do you need in order to do a latent class or latent profile analysis. There are certainly, it's difficult because this is often an exploratory approach, right? We're not sure how many classes are out there, and so it's somewhat of a guess. So doing a power analysis on a guess is difficult to do. There's a rule of thumb that says 500 is a good sample size to have in order to do a latent class or latent profile analysis. Certainly more than 80. And I can't tell you the paper that I read, but I know I've read a paper that says you need more than 80. But the rough rule of thumb, which is in one of the papers that I posted for you guys, says 500. Actually, it might also say more than 80 in that paper. The 10 commonly asked questions about latent class, latent profile analysis. The rule about how many people should be in each group, it really boils down to what you can really argue for. But I believe in that same paper, 10 questions, it says more than 1% of your sample. If it's less than 1% of your sample in a group, then it is probably an unstable group.
I've read 5%.
What's that?
Like less than
You've read
5%?
5%?
Yeah.
I mean, the paper that I just got accepted is 6%. So it's very, like, I'm right on the edge of that. And it probably varies based on sample size, right? So if you have 100,000 people, then having a group of 100 is not so terrible, right? Having a group of 10 with 100,000 people would be problematic. Having a group of 10 with 1,000 people would be problematic. So, yeah. Anyway, those are kind of rough rules of thumb, but and I think that there's a lot of debate about what the appropriate sample size is in general and how to calculate power. You can, of course, after you run a latent class analysis, go back, do a Monte Carlo simulation, and figure out exactly what your power is for a given study to detect each class. And then you can report that and say, like, I was underpowered, but it showed me this number of classes or whatever. Right? So if you have, for example, 10 people in a class, you're probably going to be underpowered for that almost regardless. So, all right. So I'm going to delete this stuff for right now. We're not going to worry about this. We're going to come down here to plot. So plot type is plot 3. Plot 3 is the plot for latent class analyses or latent profile analyses. And then we are going to do file save is local save.txt. I'm only doing this because sometimes you want to identify your classes, pluck those classes out, and use them for some other type of analysis. Could be an ANOVA, right? Like ANOVA are looking at differences across classes. Of course, you can do that right here. You can do the basic ANOVA piece without ever having to pluck this out. But if you put file is this, and then you want to save the probability of being in a class, right? And then you just say format is free. That's just going to be a free text file. We have Tech 11 here, and let's throw in Tech 14. See what happens. If you're going to specify these, if you're going to specify that you want this file to be outputted or saved, it will save it in your folder, whatever folder you guys have. You need to specify the ID variable, especially if you want to merge this with some other data set, because if you don't specify the ID variable, it will just give you the audit scores and the classes, but you won't be able to link that back to your data, right? So you need to have a way to link it back, and by saying ID variable is ID, you can do that. It actually needs to be an actual ID variable. Notice up here in names, ID variable is the first variable. So you have to have an ID variable in there in order to say ID variable is, but anyway, as long as you do that, it will put it in your data. So let's go ahead and save this, hit run. Let it run for a little while. We're looking for 2 classes, and then we're going to go through and determine if these 2 classes are, if we actually have 2 classes in our data, or if it's superior to 1 class, or basically no class, right? All right, so it ran. Everything looks good. We have some warnings, but we have no errors, so that's good. We always have warnings. We've got 1,800 people, almost 1,900 people, 5 shy. We have 1 perturbed or unperturbed value. That's actually not a big deal. Our best log likelihood was replicated over and over and over. And as long as your best log likelihood was replicated, you don't have to worry about this. Notice here we do not get our chi-square test that we've been getting in the past, right? This is because we've moved to latent profile analysis, and you just don't get it with latent profiles. Entropy, 0.904. That looks pretty good, right? So far, oh, what's our BIC? Somebody want to write this down? 39989. I mean, in our sample, in class 1, we have like, that actually doesn't tell us that much. Let's scroll down here. Here are our mean scores. And this is quite telling, right? Mean audit for audit 1 is 20. That seems really, really crazy. Actually, that can't be right because the audit, you can't have a score of 20 on audit 1. Let's go back. Let's do this. I don't know why it's saying that. There must be something in there. Use obs. R audit 1 is greater than this is weird. Why would it give me 20? Maybe that is right. Let's do that. Let's look at we'll have to check our range of our data here in a second, yeah. It says audit 1 goes all the way up to 20. That is odd. All right, we're going to roll with it for right now. We still have 0.904. Did we lose any people from this? No. All of these people have an audit 1 score that's greater than 1. That makes me think that...
It seems like audit 1's like an aggregate variable or something.
You know what I bet, actually? I bet that this I bet age got deleted out of here. Let's see. Because 20 seems like pretty average age for college students.
18 too, so that would actually make sense.
All right, let's see what happens here. Oh yeah, that reduced our sample size quite a bit. So these are going to be only drinkers. I don't want to do that with only drinkers. I want to use everybody. So let's fix this again. Yeah, names has to match the Excel file, and it didn't. I was missing one in there. And so it assumed that audit 1 was age, yeah.
Audit 1 is not the variable name in the data set.
Yeah.
It's a label that we're given it.
Yeah, it's always, the data set is just a bunch of random numbers. Actually, if we look at it, yeah, if we, where's my, just out of curiosity as I'm pulling this up, anybody ever written a book chapter before? Co-written a book chapter? And I just did my first one, and I tell you what, that will be also my last one. No
Hey,
way.
you start getting them royalty checks though.
Do you get royalty checks? I don't think I get any royalty checks. Not for an
academic.
academic.
You write like an entire book.
Yeah.
on it.
Yeah.
I even have to pay for my copy.
You did?
Yeah.
I wouldn't be surprised if I have to. That's the
I got a
worst.
discount,
Was it like entire-
Okay, so here's what the data file looks like, right?
Uh,
Yeah, almost certainly that is age. So here's the data file. There are no names. You assign the names. All it is just a random string of text data. But you can see there's like, this is the ID. Clearly that's not audit 1. That is clearly age. So, all right. Let's not save that. And it did run. And so it also should have given us a data file. I don't see the data file in here. Is it saving it somewhere else? All right, we'll come back to it. We'll search for it and find it. But all right, possibly my computer is saving it in some weird spot. All right, so we're comparing a 2-class model to a no-class model. We have entropy of 0.911. Our means down here, these look better. Here are our means for class 1 on audit. And here are our means for class 2 on audit. What we can see from this is these are people who drink very heavily and have all sorts of problems. These are people who drink very lightly and have very few problems. Just out of curiosity, You guys who ran this on an off or yeah, did you guys get a profile? Did it pop one up for you?
No.
No? Okay, for those of you who didn't, can
You have to
you?
be in diagrammer?
No, you shouldn't have to. Can you go?
Text file for sure.
What? Can you go File, Open, and click down and see if there is a GF5? Do you guys have an option to open like GF5?
Yeah.
Oh, I do have that. Yeah, yeah, yeah.
Open it up once.
But there's no file. It's just like
Yeah.
I had a file, but it's totally blank.
It is. When you open it up, it shows nothing.
Yeah.
Okay. I mean, since I have a Mac, I never monkey with that anyway because I know that I can't see it. I remember when I had a PC, it would like open every time I ran it. I wonder why it's not opening for you guys when you run it. Hey, if you go like this, can you click on diagram?
it's grayed out.
Everything's grayed out.
The
What's that?
Yeah, the options are grayed out.
All the options are grayed out.
Oh, all right. Well, never mind. Anyway, if we continue scrolling down here, we see that our two LRT tests suggest that what?
It's significant. It's a good class so far.
Different. It means something else. What does that mean? It means two classes are better than one, right? Two classes are significantly better than one. Same thing here occurs. All right. So what is our next step? If we find out that two classes or two profiles are better than one profile, try three. Why not? So, oh, does anybody remember what was our BIC? Was it 39989?
Yeah.
Okay. Let's try three. See what happens. All right, so now we have three classes. Oop. We run into our first error. It says problem involving parameter number 26. This is in class 2, the mean of audit 6. Audit 6 is physical dependence. I can tell you that in class 2 there probably is no physical dependence, and I'm guessing that across the classes we're going to see no physical dependence. I'm not concerned with means. As long as it's not a variance, and since it's in brackets, it's a means, we should be just fine. Our best log likelihood was replicated. We have no unperturbed. We're good to go there. We see that we have a class of 1200, a class of 500, a class of 98. Our entropy actually went up, which means that we're able to discriminate groups even better. Let's have a look at class 2. 1 is actually the lowest value on audit 6. These all range from 1 to 5. And it fixed that to 1. I'm totally fine with it fixing that to 1 because that probably means that there just is nobody with physical dependence. The same actually happened in class 3. So we have some physical dependence going on in this class. It's actually quite high. And then in class 2 and class 3, no physical dependence. If it's just a mean, I'm not concerned about it. I'm going to scroll down here. I'm going to have a look. Ooh, this suggests that we should stop right here, right? This says, hey, we need to go a little bit further. Let's go a little bit further. Let's go LRT starts equals 110. Let's try that. Actually, let's do 120. Let's leave this at 20 and 5.
Does it have to be 0, 0 first?
Oh, yes, thank you. 0, 0. All right, so we'll let this run for a little bit. Our problem here could actually be, we'll see, it could actually be that it doesn't like that we have a class of people that don't drink at all. or that we're including non-drinkers in this, because we are including non-drinkers. Scroll down. We still have this class 2 audit 6. BIC, though, decreased a lot, right? From 399 to 292. Entropy looks really good, 933. That still looks the same. And now we're able to say like, oh, but the parametric bootstrapped one is looking significantly better. This is what I see more often than not. Anyway, for argument's sake, right now we're gonna roll with this one. We're gonna say like, okay, so it says that this LRT is good, our BIC is lower, our everything else looks better. What we could do is we can come in here and go, let's try this. In class 2, we're going to put,
What's like the percentage in
that's just
pounds
telling
per
it that it's
cell?
class 2. C pound is whatever, and then whatever class it is. So C stands for class, and then the pound is the number of class. So it was in class 2, we had an issue with audit 6, right? We're going to fix audit 6, oops, to 1 in that class. And we're going to roll with that. Now we also saw that it was the same in class 3, right? Like that class, the audit 6 was an issue.
Is that fixing the mean?
It's fixing the mean to 1, yeah. And that could be what's causing us problems with the LRT and the MLRT, but not the BLRT. The BLRT doesn't care about that piece of it. And then, of course, now we're seeing problem involving the following parameter 41, just plain old class 2. All right, let's scroll down here. Entropy still looks good. BIC should be exactly the same because it had fixed that mean before for us. That doesn't fix this, that stays the same. All right, we're not going to worry about that for right now. We're going to delete this out, and we're going to assume that the BLRT is the one that we're going to use. Our entropy was better, our BIC was lower. Shoot.
If you have conflicting results like that, are you inclined to just lean towards the bootstrap one?
It depends on what I get in class 4, but I would report both. My preference would be to say like, hey, this one said this and this one said this. And so that was at least enough evidence for me to continue on and test against 4 classes, right? All right, 4 classes. Just real quick, we can do one other thing. Like we can change this, and we can run this 3-class, this 3-class model like this, and see if that helps fix that LRT. It's going to give us a lot more mixtures. I honestly don't think it's going to have any effect on the LRT. We'll see. We're going to be here for a while waiting for this one to finish. Check your Facebook, check Twitter. Oh, there we go. Okay. We still run into the same thing. Notice that our classes actually changed now, and now it says class 1. And so anytime you make a slight change, you might run into that. Now class 1 is our heavy drinking class. Notice our means actually shifted a little bit for class 1 too. As we scroll down, that is exactly the same. That is exactly the same. All right. So let's go 4 classes. Hit save, hit run. Let's see what happens. and I changed it to 100 starts, it's going to do that through all 4 classes, so it'll take a little bit of time. There we go. All right. Scroll down. 1 perturbed starting value. Best random likelihood was replicated. We still have this issue with audit 6, but it's fixing it on its own, so we don't have to worry about it. We now see that we have 4 classes. Our entropy dropped just a little bit. That is qualitatively a little bit, right? I mean, yeah, it's quantitative. It did go down by a number, but it's still good. Yeah. These numbers here show us like how good our classification is. If people were in class 4, like perfectly was able to place them into class 4, and the rest of them are pretty high. This is akin to your likelihood of matching somebody to a class in logistic regression, right? When you use logistic regression and you're trying to predict whether they were a 1 or a 0, it's the same basic principle. We have 4 classes. Audit 6 is getting fixed all over the place. It's not uncommon because in college students you don't see a lot of physical dependence. I have a sample of 1,200 people, and we just showed a class of 20 of those people that had physical dependence, right? The rest didn't. Anyway, so far everything that we've seen, including BIC, which was lower, right? BIC is 27. It was 2,900 before. And as we scroll down here, oh, now all of a sudden 4 classes is better than 3. And so this might be good evidence that we should stick with 4 classes. We run into this thing again, so we maybe need to up our value here. And you can get into some ridiculous numbers with this. Let's change this one to 50, and let's change this one to 200, and let's run that again. See if that fixes it. That may or may not fix it. We'll see. Anybody? Oh, so did I ask last week who went to see Joker? I did not ask last week, did I?
I don't remember.
Have I even seen you guys since I saw Joker? Probably. It just came out last week.
Yeah,
I couldn't
months
have.
No,
ago.
you did mention it.
Hey,
Oh, okay. So you guys have seen it now. Some of you have seen it.
Yeah.
I don't want to spoil it or anything.
There's a podcast on it that goes into some very interesting theories about it.
Really?
Yeah.
Oh, what's the podcast
It's
called?
called Not Another Movie Pod.
Oh yeah. So I've heard that and I've never looked at it.
Yeah,
I
check
haven't
it out.
listened
It's
to
really
it.
good. And they go into the Joker.
Office fans. There was Office fans in here, right? Have you guys started listening?
The podcast?
yeah.
Yeah, I saw that. I haven't started though.
I
yet.
listened to the first one, most of the first one this morning. It's interesting. There's a no, sorry. Okay, let's scroll down. All I really care about is this BLRT test. There we go. By making that adjustment, we now get a BLRT test that's significant. And I think that this is good enough evidence for us to say, like, okay, we can choose 4 classes over 3, and I think it's okay to roll with 4 classes. The 4 classes that we have seem like they have sufficient numbers per class. The lowest one is 98, and that's still 5%, right? So then we have a class of 100, which is 6%. Like, I'm cool with both of those. Then we have this class up here. These are going to be like very light drinkers. My guess is these are the real problem people. All right, what's our next step? 5 class model. Let's give it a shot, see what happens. Change it to 5. We hit go. That sucker is going to run for a while. Back to our discussion of podcasts.
So did they literally just watch the episode and just talk about it?
They watch episode 1 and they talk about it. And there's this interesting part in episode 1. You know, Michael, do you remember episode 1?
Yeah.
Michael sits down with Jan, and it's the one where she's like, "Where's your agenda?" And he goes, "Me no get agenda." And she was like, "Pam, where's my agenda? Why isn't it in my hand?" And she said, "Because you told me to put it in the garbage can, which is a special filing cabinet for memos from corporate." Anyway, Todd Packer calls, and Todd Packer is like the worst person on the show. and they put him on speakerphone, and he says the most inappropriate thing about the woman that Michael is sitting with. And then Michael goes, "Oh, that's sort of funny." And I was like, "Oh my God, I can't believe he said that." You have to watch the show to realize how inappropriate it is, and the comment that is just completely inappropriate by Michael. But anyway, the voice sounds like the actor that plays Todd Packer in season 2. It's not him. And so, like, I was shocked to hear that. Like, wait, no, it sounds exactly like him. And Angela Kinsey was shocked to hear that too. She was like, "No, that's him." And Pam was like, "No, not Pam. What's her name? Jennifer Fisher." It's like, "No, I emailed such and such." And I was like, "How did you get him to do that for the first episode, not knowing that he was going to even be there?" And she was like, the guy was like, "No, it wasn't him. It was some other, like, voice actor."
Oh, wow.
Yeah, but it really sounds like him. Okay, let's have a look at our 5-class model. 2 perturbed starting values, but our best log likelihood is replicated. I'm not too concerned about that. Again, we've got issues with audit 6. We will continue to have issues with audit 6. We now see that one large class of light drinkers has been divided out. We still have our 2 classes of these are probably going to be our really problematic people. Entropy is 0.91. That looks pretty good. Scroll down here. That looks good, right? Whoops. That looks good. What do we conclude from this?
What is BIC value?
Oh, that's a good question. Last time our BIC value was 2700 something or other, and now it's 2672. It's lower. Yeah, it's getting better. I would say a 5-class model looks better than a 4-class model, right? So we had this one hiccup where we had some conflicting evidence about whether or not a 3-class was better than a 2-class, right? We continued going, and we see that, okay, actually our entropy is staying really high, and 4 is better than 3, and 5 is better than 4. So now we're at a spot where a 5-class model looks pretty good. What's the next thing we want to do?
6 value.
Yeah, let's look at 6 classes. Let's see how far we can go. 6-class model. Our BIC value was 2600, right? 26.7, I think is what it said. 6-class model is going to take quite a while to converge.
So what was that episode in The Office that you didn't like? You mentioned it on
That episode is so good.
Which one?
The Michael's movie, when he actually shows his movie.
Did I say I don't like that?
Well, you said you didn't
Yeah,
like it
the
at
first
first.
week.
and then-
Oh, did I say this on a video?
I don't
when did I
remember
say
if it
this?
was on the video.
You're right. Like, I did not like that episode at first. I just actually commented on a Facebook post about this. Like, there's like an Office Facebook page that I follow. But anyway, somebody said that they hated Threat Level Midnight, and I used to always skip past Threat Level Midnight because I didn't like it. The first time I saw it, and I was like, "Oh, I can't stand this." It's the one where Michael makes a movie, and then I started watching it, and I was like,
I love that.
I love this episode. Actually, it's 2 episodes in one because you get like Threat Level Midnight, and then you also get the reaction of everybody that's going on, and you get the fact that Michael transitions away from like this thing about how important it is to the idea that it is kind of a joke, and he's okay with it being a joke. And I just love like I love the transition that Michael makes in that episode. It's a great episode. It really is. Yeah.
A friend of mine in New York, he went to see a play and actually did the Threat Level Midnight episode.
Oh, really?
Yeah, so it was like a reenactment or everything like that. It was
That's awesome.
Yeah, he said he liked it a lot.
So they have an off-Broadway show that is The Office. Do they just pick different episodes?
I don't
It's
know.
not the same episode every time,
I
or
don't know.
okay.
It's interesting though.
So 6 classes. Let's have a look here. So 15 perturbed starting values. Our best log likelihood was not replicated. That means we need to go back and rerun this model. But before we do that, let's have a look at some other things. Now we've got audit 10 that's becoming a sticking point, but it's just fixing the mean. We're okay with that. Our BIC dropped quite a bit, actually, right? Dropped by 400. But we also have some issues with the model, so we can't really trust. Actually, even if we fix it, that BIC won't change. We have a class of 6 folks. That is 0.03%. that's an indication that there's a problem here.
Why are those columns not labeled?
What do you mean?
It doesn't say that this is the number of people in that.
Oh, because it does down here. Class counts and proportions. Sorry, like these are the actual numbers of people, right? Entropy actually looks good, 0.94, but a class of 6 is still problematic. We come down here. And that is not significant. That is significant, but we wind up with an error warning again. And we can try something here. Let's go with 250. And let's go with 300 and 100. And let's see if doing more mixtures can fix this problem that we're having.
So at what point do you stop trying to increase mixtures?
This will be the last one.
Okay.
Yeah. In fact, there are people that say that you shouldn't go beyond 50. I went to 200 here.
Is
But
that something that you typically would report in a paper? Like what you're...
I think you can. I don't think it matters. I think that it's that most people don't care as long as your model is converging, right? Then people are okay with it. Yeah. I also feel like the expertise out there to review a paper of latent class modeling is low. I'm guessing. I've submitted a few of these papers, and even I don't know if I bet out of maybe like a half a dozen reviewers or a dozen reviewers, one of them really knew what they were doing when it came to latent class modeling. And most people are like, oh, this is a very complex analysis. And I thought, it's not really that complex. It's like it's touchy, but it's not as, I feel like SEM is much more difficult. Like this, you just keep plugging in more numbers and hit and go, right? Seriously, that's all I'm doing. Can I get this to converge right? Can I get this to converge right? What if I up the ante? Can I get it to converge right? And eventually you just give up and say, no, I can't get it to converge right. There must not be 6 classes, right? And then you step back down. So far on that last one, I would say the evidence is against 6 classes. Even though the BIC went down, entropy,
It's, we have that one class
it is what it is.
1%,
A
too.
class of 6 people would suggest that that's not a good class. This would be enough evidence for me right now to stop and say, like, I'm not going to go any further. I'm going to accept the 5 classes, which fit great, right? The 5 classes look fantastic. 6 classes, if I could just get that bootstrapped LRT to say, no, this is garbage, then I feel really good about canceling out 6 and going with 5. But I think even if you said, like, well, there's mixed evidence and I'm going to try and roll with 6, as a reviewer, I hope a reviewer would say, like, you can't have a class of 6 folks in a sample of 1,900 people. That's ridiculous, right? Yeah. So throw those 6 people somewhere else, or just pull them out of your data set. That would be my thing. It could be 6 outliers, right?
So have you gotten pushback from reviewers in terms of like using the technique or stuff like that, or is it just kind of more slow?
No, I just feel like I don't get any comments on it, to be honest. Like, they just don't say a word. And yeah, right? If they said, yeah, it's odd. Yeah, it's a good way to describe it. All right, so we did a whole bunch of mixtures there. We still can't replicate the best log likelihood. And if you look here, what did I do? 50 of these? Yeah, I did 50. We can go back and do 100. Maybe we should, just to check. We still only have 6 people in that class. Let's have a look down here. Ooh, and look at there. This is what I was talking about when I said sometimes I just can't trust this thing, right? Yeah, it's showing like, hey, yeah, 6 people's better than whatever, and I just don't like that idea. So, in this case, I would report both and be more inclined to rely on this one and the fact that there's only 6 people, right? That would make me say, no, I'm not cool with it. But in order to do that, I really want to be able to have my log likelihoods replicated, because without that, then I feel like all of this is kind of a wash. If we could get all of those log likelihoods replicated, I have a feeling that BLRT would go away. But if you can't, then I think that that's another good piece of evidence to say, like, it's unlikely that there's 6 because I can't get this last log likelihood to replicate in the final stage models, in the final mixtures. So. Anybody go and see Gemini Man?
Gemini?
Yeah. I'm a dad. That is such a dad thing, right? No, nobody went to see Gemini Man?
That's a hard pass.
Thank God.
Did you see Peanut Butter Falcon?
I didn't.
I
No.
want to go see that.
I want to see it actually. Yeah. Did you see it? No.
Yeah, because Barrett doesn't like the theater it's showing
Well, I'm 6'4", a lot of these seats are not conducive to me sitting there for a while.
Sure.
You're like 5'2", so the world is
I ain't
comfortable for
complaining.
you.
What's that?
I'm not complaining about my leg room. I would have seen it.
Yeah. So I saw. I mean, I tweeted something about Gemini Man. Like, I'm watching the previews for it. It's Ang Lee, right? And I think I tweeted something like, if one Will Smith is great, 2 Will Smiths has to be even better. Ang Lee. You know? I don't know that one Will Smith is great anymore. At one point, Will Smith was like, you put him in a movie, like, that's it. You guys know that Will Smith turned down the role of Neo for The Matrix?
The original one?
Yeah. So it was supposed to be Will Smith and who was supposed to be Morpheus was not supposed to be Fishburne. It was supposed to be somebody else.
Morgan Freeman or Morpheus?
No, it wouldn't have been. It wasn't Morgan Freeman. But anyway, Will Smith turned it down. He's like, these 2 guys, they pitched this to me, and they're like, oh, we got this awesome idea. We're gonna invent a new way to like shoot with cameras and blah blah blah. He's like, I listened to them. It was the worst movie pitch ever. They hadn't invented this new camera shooting technique, and they're like trying to sign me up for something, and they've done nothing up to this point. Like, no, I'm not going to be in your movie. That's ridiculous. It's like, huge mistake. But Keanu Reeves actually wound up being great in that movie. I mean, Keanu Reeves takes a beating, but man, I love that guy. Actually, now everyone loves Keanu Reeves
John
lately,
Wick.
right? Like, everyone loves Keanu Reeves. But there was a time when everyone hated Keanu Reeves. I've always really liked him as a person, but also as an actor, even though he plays, for the most part, Keanu Reeves in every movie that he's in. Right? He's like Will Smith, who also plays Will Smith in every movie that he's in. But
Aren't they coming out with new Bad Boys?
Yes.
are they really?
Yes, I can't wait.
I want to see the new Batman. Oh, did you guys see that Lenny Kravitz's daughter was cast
Yeah,
as Catwoman in the new
I
the
like
new
her,
Batman?
Zoe.
Yeah, she's awesome.
I like her. She's a good actress.
Yeah, I'm excited. So, and then there's some. Oh, who's going to Zombieland 2? Who likes Zombieland 1? I just
I
gotta
gotta
ask.
watch on.
What?
I know.
I can't remember.
It is the best zombie
It's like a
movie.
funny movie.
It's not scary. It is
Oh
hilarious.
yeah, I like Tina.
Okay, so we ran 100 of these.
Something like that.
We've run 100 now, 100 mixtures. We've actually run 200 mixtures, and in the last 100 mixtures, the best 100 mixtures, we can't replicate our best log likelihood. This, again, is just evidence, more evidence to me that we should not be taking this model. If we come down here, these things are still right where they were before. I would conclude, based on this, that there are 5 models and not 6. I would not accept 6 models. And I would roll with it. So then the next step is what?
Graph.
Graphing it, right? And we don't have to graph it because I've already graphed the 5 models. Hold on just one second. I'll pull it up and I'll show you what those 5 look like because this data comes from a paper that I've already published. When I did this paper, I actually controlled for gender and age in the mixture models, which we didn't do today, but you could. The code is right there. All you have to do is go and click on it. Where? Oh yeah, I bet it's called E. This is it. This is what the classes look like. It is again audit. And so in this, you can see nobody has physical dependence. Almost everybody. I did wind up fixing physical dependence for 2 of these classes to be 1. We have 5 classes though, right? 2 really heavy drinking classes, a moderate drinking class, and a low drinking class. These classes map on very nicely to my most recent paper with one exception. We found 6 classes. We found classes that looked exactly like this, but we also found another heavy drinking class that had physical dependence way up here. It was only 20 people. It's a smaller amount, but we were able to replicate 5 classes and found a 6th class of 20 people. And that, I mean, it's random chance if you get enough people to find some people that have physical dependence, because it's just like very uncommon in the first place. Physical dependence on alcohol is uncommon. Physical dependence on alcohol amongst college student drinkers is really uncommon. We found 20 people out of a sample of 1,500. So.
Doesn't that only show 4 classes though?
Oh yeah, this one I actually removed. Sorry, non-drinkers.
Oh.
That's the difference. So in the other one, we do have. We were looking at everybody, including non-drinkers. So we probably had a class of just zero drinkers. Yeah. So all of these people reported drinking. Anyway, yeah.
How many items need to be for each of those?
For a profile analysis or a latent class analysis, how many items do you need?
Well, no. So like if you look on the x-axis, there's all those things like
Yeah.
measured others of concern, and I guess those are measures, right?
Those are items on the audit. Yeah.
So like, could you have one that's 1 item? Is that, you know what I mean?
If you have 1 item, how many classes can you have? 1 class, right?
Wait, so each of those is 1 single item? Like others are concerned, that's just 1 item?
That's just 1 item.
Oh.
Yeah, the audit has 10 items. Those are the 10 items across the bottom.
I thought like there were like 3 items for measuring if others were concerned.
Oh, no, but you can do that, right? You can actually take an average of 3 items, or you can use all 3 items. So you could do this. The audit has 3 subscales, right? In fact, where's this? These are the 3 subscales of the audit, and I use all of the items within each subscale. But I could have collapsed them down and just used like the average of these 4 items, right? Or the average of these 4, or the average of these 4. Or even more impressive, what you could do is, I've never done this, but let's walk through it, because there's something else that you could potentially do. Like we said that there are 5 classes. Let's go back to 2 classes for a second, and let's do this. F1 by, I don't know if this will work or not, but let's try it. F2 by, he is trying to see if he can use factors. That's right. Rather than items. I don't know if this will work or not. Let's have a look and see. It's probably going to tell me back up off me. I don't know. See? If it doesn't work, you can take the mean of those items, right? And then
People usually do it like that, where they have 1 construct measured by a couple of items, or like 1 item per thing.
the way that I've always seen it is 1 item per. It's never even dawned on me to try and do it with the latent variables or with something along those lines. It doesn't mean it's not possible. It's just, yeah. But if you really wanted to do it that way, I suppose you could either, if this works, you could do it this way. I honestly don't think it's going to work.
Because I think one example that I had a professor explain to me was like if you're looking at profiles of people based on personality, then you would have like extroversion, neuroticism, and then see like how like maybe if you're high in extroversion, low in neuroticism, and all that. So then you wouldn't be measuring neuroticism with one item. It would be like
A mean of
the
items.
whole- it would be
Yeah.
the whole thing.
Yeah, you could take a mean of items, right, to get a single
But
score on
usually
neuroticism.
people do it with just single items.
Yeah. Or you could do an initial factor analysis first, right? A CFA, and extract your factor scores, and then use those factor scores as your items, which would be the same as what I'm doing here, except the factor scores would now be observed variables, right? So you could do something like that. Like you can get creative with it. This isn't going to converge, I don't think. I just saw that the EM hit 500 on that last one, and it did there too. My guess is this thing is going to say like, nope, get out of town, buddy. I will give it like one more, maybe 2 more minutes. So who has seen Zombieland? Just Zombieland 1, the original.
I saw it at a premiere down in Miami, in South Miami, and Woody Harrelson joined us.
No kidding?
And the other guy.
That's cool. Jesse Eisenberg?
Whatever.
What?
Yeah.
Yeah, sure.
Yeah, that guy.
Woody Harrelson is
I love Zombieland. Hands down my favorite zombie movie.
No, I think after 20 days later, no good zombie movie was made.
28 days later?
Yeah.
You mean 28 days? Wait, yeah, there's 28 days later, and then there's 28 months, or weeks. Yeah, 28 weeks later. I did not like 28 weeks,
Yeah.
but I love 28 days
Yeah, that was the
later.
last, in my opinion.
Sandra
the last-
Bullock is amazing in that show.
Sandra Bullock.
She's in a movie called 28 Days.
Oh,
It's about rehab. No, but 28 Days Later is awesome. It's a great
Yeah.
movie. It's like one of the only.
To me, it's just that and the Romero zombie movies.
Oh yeah, all of those are pretty decent. Not as good as Zombieland. Like Zombieland is funny, and it's got Woody Harrelson,
I
and
mean, for that, I just watched Shaun of the Dead.
Shaun of the Dead is great too. Like don't get me wrong, I love that show.
Oh, it's awesome.
Yeah, it's really good, right? So anyway, this is not going to converge. I'm gonna call it quits here in a second. Any questions about what we did today? I don't have anything else to show you guys. I'm not going to graph this out. Oh, I was going to do one other thing, wasn't I? This has nothing to do with latent class analysis. I'm going to just have to quit this. It's M plus related, yeah. We can just use this. That's fine. File. Save as. I just really quick wanted to walk you guys through one more time. Get rid of classes.
I have a question.
Shoot.
So when we started, you likened this to putting an egg back together.
Mm-hmm.
So does that have anything to do with the fact that entropy is in there, that we're measuring entropy being steady decline into disorder?
Say that again?
So entropy, right? In thermal.
Yeah, no, don't think of it in terms of
So that's
thermodynamics.
why I was looking at it. But it makes sense the way that you described it as putting.
I had a similar idea actually when we talk about entropy, that it actually with the randomness, because when you increase the randomness in any physical things, entropy increases.
Right.
So if I think the model is more random, I think the entropy might increase, but it gives certain level, and then it becomes more fixed and it gives more effective.
Right, the lower level, lower amount is more fixed.
Yeah, it's the opposite in physics, right? Like
Yeah.
lower entropy is more fixed, right?
No, higher entropy is less fixed.
Higher entropy is random.
Yeah,
Higher entropy is more random. Yeah, in physics,
Yeah.
and so it would be the opposite here
Oh,
because
okay. That's
higher
what was
entropy
kind
is
of
less
throwing me off.
random. Yeah. Yeah. Hold on. I'm gonna stop the
But
recording.
it did make sense with your example.